So first thing that we're going to do over here is to declare a data buffer, right? So let it just go ahead, and we know that our send and receive function work on an UART data, right? So if you go to UART PS, okay, you could clearly see that our UART PS send, okay, expect the data to be in U8 format, right? So we go ahead and we declared U8, right? And let us just name this as data, okay? And this will be an array consisting of an 11 elements, right? And we'll also be initializing it to, let us assume, hello world, right? So if you count the number of bytes that we have, right? So we have 1 2 3 4 5 6 7 8 9 10 and 11, right? So 11 characters are present, and each character can be represented with an U8. So this could be stored in this array, right? So once this is done, now this will serve as the data buffer for us, right? Now we call a UART send function, right? So we'll just be going ahead, and then okay, after we perform an initialization, we call send, right? First argument is an instance structure, which is UART, and then second argument is the pointer to a data buffer, right? So here we could just add an ampersand, and then we could mention the address of our 0th element of an array, right? So this is how we represent the pointer to our data buffer. The other method that you could use is you could just mention data, right? So this will be the second way that you have, which will be providing a correct address for our data buffer, right? But the easier way will be to use an ampersand and then data 0, right? So this basically means the starting address of our array, right? So once this is specified, the next is to specify the number of bytes that we want to transmit. So here we want to transmit 11 bytes, right? These are all the arguments that you want to provide to our UART send function, right? Now if you just read the description of this function, now this function have a different behavior considering the different mode, right? So we are utilizing a pool mode over here. So in a pool mode, this function will only send as much data as tx FIFO can buffer, right? And if you exceed the size which tx FIFO could not hold, then in that case you need to repetitively run an application, right? There's also return the number of bytes, okay, actually sent. So we need to wait till we reach to the value of 11 because we want to send 11 byte, right? So how we do that is, let us just store this value, okay, in one of a variable. Now we know that this is written s32, right? Let us just name this as count, okay, and initialize this to a 0. So let us just copy this, okay, declared it over here and initialize it to a 0, right? So this variable will keep a track of the number of bytes that are actually sent, right? So while we could just use while count is not equals to 11, okay, we could just wait over here, right? So we could just update the value of a count, and then we'll again be checking whether count is equals to 11 or not, right? Okay, and as soon as our count becomes equals to 11, okay, we'll be simply coming out of the while loop, right? And in that case we could just mention data, okay, sent successfully, right? This is a one of a way that we have with us, where what we are doing is we are calling UART PS send function, and then this basically returns the number of bytes which are actually sent, and we are waiting for our count to reach to a value of 11. So as soon as count reaches to a value of 11, we'll be coming out of a while loop, and then we'll be sending the string data transmission or data send is successful, right? Now here we need to verify whether this returns byte by byte, that is with each new byte sent, whether it returns 1 or the total bytes that have been sent so far, right? So that could be verified like this. So let's just go ahead and build an application project, okay? And what we're going to do is, with each new iteration, okay, with each new iteration we'll also be printing the value of count, right? So count, okay, %0d, and then let it just try to print the value of a count, right? So if you just try to build an application project now, okay, and then debug as launch on hardware. So we do not need to do any changes to a whitelist serial terminal since we properly configured it to work at 9600. And now you could see UART init is successful and hello world, okay, that is what we received. Then count is 11, right? And finally data send is successful, right? Okay, so we will be waiting for all the 11 bytes to be transmitted, and then we'll be coming out of this while loop, and then we just mention data send, okay, successful, right? This is what we're going to do. Let it just proceed to build an application project. And once our build is successful, okay, we could just go ahead to our whitelist terminal, okay, and then we could just go ahead and relaunch our debug session, right? So this will automatically reprogram our FPGA. And since our YT serial terminal is already connected to the correct baud rate as well as correct terminal, we just need to go ahead and click on resume button, right? So you could see UART init is successful. Then we have an hello world and data sent successful, right? So we able to send our data correctly. Now you could just add a new line character between hello world and data sent successfully, right? So here we could just add a new line character. Let us just again rebuild our application project and then try to run it on an FPGA, right? So again we will be relaunching our debug session, and then once this is done, we'll just be clicking on a resume button, right? So you could see UART init is successful, hello world, and then data sent successful, right? So the hello world is the data that we have in a data buffer, right? So this is how we could proceed sending the data to the UART terminal, right? Now the next target will be to understand how we receive the data from the serial terminal, right?